Correlation measures closeness. Near 1 means strong. Near 0 means weak.
Welcome back to the estuary census. When we map out our data, we want to know how tightly those individual crabs hug a straight line. To track that, we use the correlation coefficient, R, scaling from -1 to +1. Near +1, points cluster on an upward sloping line. Near -1, they stick to a downward sloping line. Near 0, they scatter into a shapeless cloud. This single number allows us to compare different sets of data by looking at two things: the sign, which shows the direction, and the size, showing the strength. In this study of how study time relates to quiz scores, our data points look like tiny silver fish swimming past a great blue heron. For this set, the correlation coefficient is 0.93. Because 0.93 is close to +1, these fish lie very close to an upward sloping line. This is a strong positive linear association. The high R value reflects that as study time increases, quiz scores tend to increase as well. Comparing two datasets helps us see how R behaves. Here, dataset A has an R of 0.82, while dataset B has an R of 0.18. Based only on those numbers, which dataset has the stronger linear association? Strength is measured by how close the number gets to 1 or -1. Since 0.82 is much closer to 1 than 0.18, it represents a tighter fit. That makes dataset A the one with the stronger linear association. The distance from 0 tells us the strength of the relationship, regardless of whether the points are moving up or down. Now we look at outside temperature and heating costs. As the fox watches the snowfall, our technology gives an R value of -0.88. That negative sign means the variables move in opposite directions. As temperature goes up, heating costs tend to decrease. Even though the direction is downward, the large magnitude of 0.88 means the snowflakes are packed tightly to the line. These variables have a strong negative linear association. The negative sign indicates an inverse relationship, but the high value proves the connection between temperature and cost is highly predictable. We can see the full range of R here on the wet sand. The sign indicates if the line goes up or down, and the magnitude indicates how physically close the points are to that line. Combining the visual evidence of a scatterplot with the numerical evidence of R provides a complete description of the patterns we find in the census. Before we head back from the estuary, think about the data we've seen. What is the correlation coefficient?
Check the direction. Check the strength. Let data guide you.